Oh, we've talked so much about PFAS recently, haven't we? Particularly with the court case that's been going on across the country, but also the rather particular instance of PFAS contamination at Wreck Bay, in Jervis Bay, the Wreck Bay community, of course, being compensated in part for the contamination of Mary Creek with PFAS chemicals that were used by the nearby defence base. PFAS is in lots of things, though, not just these firefighting foams. There's a lot of news about PFAS overseas as well, with top US chemical firms ordered to pay about $1.2 billion to settle water contamination lawsuits. Can this stuff be cleaned up? Interestingly, it's found in a lot of places. There are lots of different types of PFAS. And now Shoalhaven Council has become the first council in Australia to use this particular PFAS remediation technology. I spoke to Peter Murphy, who's from the company EPOC, and he's the EPOC Enviro. He's the managing director there, and asked him to explain how this particular PFAS remediation technology that's being installed at the West Nowra tip at the recycling and waste facility there, this first for Australia, how it works.
It's a system called a SAFF, or SAFF, which stands for Surface Active Foam Fractionation, and it's a process for removing PFAS chemicals from water. So specifically at that site, it removes it from the landfill leachate, which is the water that percolates through the landfill and collects at the bottom of the leachate. And then normally that's discharged into the sewer system, but we intercept it before it goes to sewer, and we treat it and strip the PFAS out so that it can then go about on its way.
Okay, so this is PFAS that leaches into landfill, is that right?
Correct. So, well, I guess, landfills are a receptacle for a lot of products, as you can imagine. Like, all sorts of junk goes into them, and every lounge, every bit of carpet, every shoe, every pieces of clothing and Teflon cookware and whatever all carries PFAS. In minute volumes, it gets progressively washed out and washed down through the landfills over time. And so the landfills now have an issue with this PFAS chemical, and PFAS is a broad group of many thousands of chemicals. So we target a few specific ones, but it takes, I think there's about 14,000 PFAS compounds in the world. But our job is to target a few of the ones that they call the long-chain PFAS, which are the more problematic ones, and we strip that out of the water before it's allowed to be discharged to sewer.
Problematic meaning potentially more harmful to human health, maybe? Is that what you mean by problematic? Or
Yeah, so it's toxic in that it has known issues with human health around endocrine disruption and cancer and fertility rates and birth defects and all sorts of nasty stuff. It's cumulative in that it almost never breaks down. That carbon-fluorine bond, which characterises the fluorocarbon chemistry, is the strongest bond in nature, so it lasts for many, many years, literally hundreds of years sometimes. And it's also bioaccumulative, so it gets uptaken by plants, which gets uptaken by small animals, which ultimately gets uptaken by taken in by humans, and it accumulates in our systems and in the dense protein of our bodies, and it can't be expelled, and so it causes problems.
Now, foam fractionation, is there a way of just describing how this works in layman's terms?
Yeah, there is. So one of the characteristics of a lot of PFAS compounds is they look a bit like a tadpole. They have a functional head chemistry, and then they have a long fluorocarbon tail, which is a series of carbon molecules with two fluorines on each molecule. And that tail is hydrophobic. It doesn't like being in the water, and it has a preference to sit on the face of an air bubble. And so we just take those contaminated waters, those leachate waters, and we put them in a vessel, and then we circulate and saturate that vessel with air bubbles. And as those air bubbles rise to the surface, they carry the PFAS materials with them, where they present as a foam, because that's what PFAS chemistry does, it foams. And then we harvest that foam, and then we go about concentrating it down into the smallest volume we can. And typically if we're treating groundwaters, we can usually get a concentration factor of 3 or 4 million times, which to put it in context, is about a teacup in a swimming pool worth of water. And in landfills, it's a bit more. It's more like a bucket in a swimming pool worth of water. So we reduce it down into this very small volume, and then we're able to hand that over to some of the destruction technologies which are out there, which can actually permanently destroy the PFAS.
Okay, so it doesn't have to be stored in some kind of condensed way. It actually gets destroyed, does it?
Correct. So in the US, we've just launched a solution called Forever, which is a kind of play on the forever chemical thing. And it's actually a combination of a supercritical water oxidation system, which destroys the PFAS. It strips the fluorocarbon bond and breaks that chemical down into harmless minerals and salts, then removes it from the environment forever. So that capability is there, and we're working with pretty much every destruction technology provider in the world. We do a fantastic job of separating and concentrating PFAS, and then we hand it over to these destruction providers who then destroy it. But there's a number of them.
Now, you'll be implementing this system at Shoalhaven Council, which, as I understand, is, as I said, the first Australian council. This will be removing the PFAS from a contained body of water, which is the water that will then be used in this kind of a closed circuit to wash recycled glass, etc. And I can imagine how that might be an easier task than cleaning up PFAS from, say, a creek or from someone's groundwater or from someone's property. We've just seen the massive multi-million-dollar payments that have been handed out to people as compensation for contamination of their land due to PFAS, so a type of PFAS, of course, from the firefighting foams largely. Can this system be used to clean up those sorts of messes as a result of PFAS?
It can. I mean, one of the benefits of foam fractionation as a process is it works from extremely low concentrations in the single-digit parts per trillion realm, right up into many, hundreds of thousands of parts per billion. So, 3, 4, 5 orders of magnitude higher concentrations. And so the benefit of that is, it's hugely effective on some of these low concentration waters as well. And so we've got a project in Minnesota at the moment, which is kind of ground zero for some of the 3M PFAS contamination that's happened there over recent decades.
3M being some of this most toxic a form of PFAS through the firefighting chemicals, etc. Is that what you mean?
Correct. So most PFAS chemistries have their own signature, like a combination of different PFAS materials that make up that particular mix. And so one of the more problematic ones, because it contains materials called PFOS and PFOA, they're the two products that are about to be classified as hazardous substances in the US, and they've been added to the Stockholm Convention, which is the United Nations Convention on Persistent Organic Pollutants. So they really want to target the removal of those ones. So we've been removing that initially from groundwater, and now we've just moved to a surface water trial where we're stripping it out of the creek. So we can do all types of waters, all water matrices. We can do drinking waters. We can do reverse osmosis reject waters. We can do industrial waste waters, leachate waters. Basically, if there's PFAS in an aqueous mix, we'll get it. So.
Is it expensive, though, to do? I'm wondering, I'm sure there are people listening who think, well, why can't we?
Yeah. Oh, look, the plants are relatively complex, I suppose. They're fairly highly engineered piece of equipment, but most of our plants will do somewhere between 500,000 and 1 million litres a day, so they have a pretty high throughput. And the cost is really low compared to other treatment technologies because we don't use any consumables. We use relatively little power to move the water because all we've got to do is generate air bubbles. We're not pushing it through membranes or using any high-energy approaches. We use relatively little labour. The systems are designed to be autonomous and stand alone and just keep chugging away like an old sort of tractor. And so in terms of cents per treated litre, we would argue that it's the cheapest technology. It doesn't get any simpler than using air bubbles to strip this stuff out.
There we go. That's Peter Murphy, the EPOC Enviro Managing Director that's provided this technology to Shoalhaven Council, installed for the first time in Australia by Shoalhaven Council there, and it'll be this kind of closed circuit where it'll be used in the leachate water. The water will be used to clean the recycled glass, etc. It's all part of this kind of closed system. It's pretty interesting stuff.